Cities are often found to be significantly hotter than their suburbs due to the urban heat island effect. When an urban area is built, the vegetated surface and soil surface is replaced with impervious surfaces, such as concrete paving and building materials. There are also a greater number of people driving cars, using energy, and all of these activities either create or retain heat, causing the city to warm at a greater rate than its suburbs and rural hinterlands. Thermal conditions can greatly affect the quality of living in urban areas. Designing climate-adapted cities with thermal comfort in mind encourages the use of urban space and sustainable modes of mobility, such as walking and cycling. As well as that, it also has numerous additional environmental, economic and social benefits. As evidence from existing literature, thermal effects manifest themselves on humans in outdoor urban spaces to varying degrees dependent on 4 distinct categories. These are physical, psychological, physiological, and social behavioural factors. Typically, these elements have been investigated in isolation, and studies have crucially failed to facilitate links between this interdisciplinary knowledge in order to ultimately inform sustainable urban design. In response to this, an interdisciplinary approach has been created in order to map thermal comfort, vulnerability, and heat risk at the hyperlocal level in order to ultimately support evidence-based governance in the city of Dresden, Germany. There is a clear need for heat mitigation strategies in Dresden in the context of extreme European weather events. Further, Dresden is known to have a rather conservative form of urban renewal due to the focus on restoring the historic centre of the city. This study focuses on the inner city of Dresden, incorporating the surroundings of the main train station, the main shopping street of Pragerstrasse, and Reitbahnstrasse, which is a mainly residential area behind Pragerstrasse. And this study was chosen in accordance with a larger area which is currently proposed for redevelopment by the city of Dresden. So, for my data collection, I decided on a route which would incorporate the mentioned areas, and I will walk along this route while collecting meteorological data on physical heat parameters as well as subjective information from pedestrian participants on how they will actually experience heat. So in terms of the physical parameters of heat, a mobile climate monitoring device has been created for this data collection purposes. And here I have the first proof of concept device, which I can show you in detail how it works. The final device is nearing completion, however, unfortunately, I can't disclose to you all of the final sensors before publication. However, what I can say about both devices is they're both being created with regards to the Verein Deutsche Ingenieure standards, and that's including resolution, accuracy, and response time. As well as that, I've also tried to create the device for as low cost as possible, while also making it user-friendly so that it can be applied elsewhere. The basis of the device is an Arduino board, which you can see here at the bottom layer of the device. Arduino products are really nice for my purposes because they're generally created as open source with easy-to-use hardware and software. As well as that, there's also a lot of online forums where you can get information on how to use them. And all the products are pretty easily and cheaply replaced if they're damaged or if you just want to upgrade them. So now above the Arduino board we have the data logger, and you can see here there's a micro SD card and an SD card inside where all the data is stored upon. Now onto the actual sensors. Here we have a combined air temperature, air pressure and humidity sensor, which is located outside of the electronics, so all the heat from them doesn't affect the measurements. And then here we have the ground temperature sensor, which is an infrared thermometer. And then finally, we have the GPS of the device, which means that all the data is being collected automatically and attributed to coordinate points, and therefore can be easily mapped. So also of note is that all the sensors use low power, and therefore they're ideal for maximising the battery life of mobile applications such as this one. And again, this is just a proof of concept device, so it doesn't have all the sensors that are going to be included in the final device. In particular, there will be the addition of a pyranometer and a globe thermometer. I'm demonstrating now the Arduino program. This is again very user-friendly. The device is connected via this USB cable, and with this you can edit the code in the program, compile it, and then re-upload it to the device. As well as that, there's also this tool called Serial Monitor, and when the device is connected via the USB cable, you can see live the data that's being collected from each of the sensors. So we have temperature, ground temperature, and the pressure and humidity. And at the moment, I've programmed it to every 1 second return some information. You can see that the ground temperature is sitting about 20 degrees because I'm pointing it at the window here. But then as soon as I move my hand in front of the sensor, you can see it jumps up to 29 degrees. And then as soon as I take it away again, it jumps back down to 20. So here I am at the south of the Hauptbahnhof, which is the start of the mobile climate monitoring route, and I have with me the proof of concept device on my back here. And typically in other studies they've used backpacks and they've used trolleys and bicycles to mount the mobile climate monitoring sensors, but I have chosen to use here this kind of GoPro strap, which is really useful because you can adjust it by height, so anyone can use it and adjust it to the same height, which is really important for the mobile climate monitoring measurements. As mentioned, as well as the meteorological measurements, I will also collect subjective measurements on thermal comfort from pedestrians, and for this I will have some of the monitoring routes pedestrian participants accompanying me while filling out a questionnaire. So this questionnaire will have firstly basic demographic information, as well as information on the clothing levels, hydration level and other adaptive heat measures by the pedestrian participants. And then at various survey points along the route, we will stop and answer questions on how they subjectively perceive the heat sensation, how comfortable they are with that sensation, and then how this feels in relation to the previous point we stopped at. And there'll also be some additional space for comments on things they like and dislike about the space. The time period for data collection is during the summer from June to August, and meteorological measurements will be taken 3 times a day, with pedestrian participants just joining me during the afternoon and the hottest time of the day. So this area at the south of the Hauptbahnhof is particularly open to development at the moment. The city has plans to move these Flixbus stops behind me to the north of the Hauptbahnhof, where the Simmel currently is, and then redevelop this area into a new and attractive entrance to the city of Dresden. Furthermore, it's really important to study thermal comfort with regards to the areas around the Hauptbahnhof, because people are waiting here for very long times on buses and trains and then accumulating heat stress very quickly. In December of 2021, the City of Dresden's Amt for Stadtplanung carried out a survey in this city centre area which is proposed for redevelopment. And it was revealed that the areas where people reported to be the most bothered by heat was in fact around the Hauptbahnhof and on Prager Strasse, which is where I'm headed now, and this will be the next stop that I show you on the monitoring route. So here I am in the middle of the square at the beginning of Prager Strasse, and Prager Strasse is the main shopping street of Dresden. And today it's a nice sunny day, so if we look at the sky above us we can see that we have a nice clear sky. Okay. The sky view factor is something which is known to be significantly correlated with thermal comfort, and it's a parameter which describes how much of the sky can be seen from the ground. And this can be captured with a simple fisheye image taken from the ground looking directly up, like this example. But when we calculate in the sky view factor, it must also be considered what kind of materials are contributing to forming the horizon, such as tree canopy or concrete buildings. So here I am right in the middle of Prager Strasse, and at the top and the bottom of the street are somewhat narrower urban canyons, and the whole street's lined with shops. But what's interesting about this open space in the middle is that there's already some green and blue spaces, for example the water features behind me and the trees that line the street. So this already gives some examples of heat mitigation for the area. So here I am in the final stretch of the monitoring route, which is Reitbahnstrasse, and now this area is largely residential. It's behind all of the main shopping streets, but it also contains a large car park, these 2 massive hotel blocks, and then this kind of large public space in the middle. Now this area is particularly interesting because it's also very open to development at the moment. The city is hosting a number of participation workshops where they're inviting members of the public to come and discuss what should happen to this area. And this area is being open to development, as well as the Grüner Bogen, which starts at the beginning of the street and extends to St. Petersburger Strasse. Yeah, so now that we've completed the route, we end up back here at this square at the beginning of Prager Strasse. In total the route was about 30 minutes long and 3.2 kilometres, and it's really good that we end up back at the same place where we started for calibration purposes, and also because there's a lot of shops around where I can buy a nice cold refreshment for all my pedestrian participants. Thank you very much for watching. If you're interested in becoming a pedestrian participant, you can express your interest by emailing me at c.gallacher@dlgs.iuer.de.